Hello friends, this video limit and derivative part 10 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 9. We'll see a theorem now. The theorem says that if fn g be two real functions with some domain such that fx is always less than gx. Example, we'll take one scenario here. Let this be fx is less than gx. So that will be two function and the greater one is gx. So let's suppose this is gx and let's suppose this is fx, right? If you see this function such a way that any point of time the value of gx is greater than the value of fx, right? Now it is saying that if limit of both this function, let's suppose take a point A. For example, this is a point A and this is a point A. So at this point, if the limit exists for both these values, then in that case limit of this function gx will be less than limit of this function fx. Very simple actually. See, if there are two functions such that they are always fx is always less than gx, that is gx is always bigger, then at any point of time if the limit exists for both fx and gx, then obviously at that point of time the limit will also have the same property, that is limit of gx at x equal to a will be greater than limit of fx at x equal to a. It's a very common sense assumptions confirm this. So this is the theorem. That's a very common sense that if there are two functions fx and gx, then gx is always bigger than fx, and at any point of in the graph at x is equal to a, the limit exists for both these values. Then at that point of time, the limit will also have the same property. So in this case, the limit of this value, let's suppose this value is L1, this value is L2. So here also L1 is greater than L2, where L1 is nothing but the limit of gx at x equal to a, and L2 is nothing but limit of fx at x equal to a. Before we start sandwich theorem, let me build a base for the sandwich theorem. Let's take, there are three students. So let's suppose one guy is topper and one guy is mediocre and the other guy is flopper. There are three people, right? Now they all watch exam fair videos. Obviously the topper watch more videos, so he's topper. The mediocre watch less videos, so he's mediocre, and the flopper hardly watch exam fair videos. So now let's assume that the assumption is the topper always watch more than mediocre and the mediocre always watch more than flop. That's the assumption. On a particular date, let's suppose on Monday, okay, topper watched for 3 hours, let's suppose for 4 hours. Let's suppose on Monday the topper watched for 4 hours, the mediocre watched for 2 hours, and flopper watched for 1/2 hours. On Tuesday, the topper watched for 5 hours, mediocre for 3 hours, and flopper for 1 hour. This can be regular statistics. On Thursday, the topper watched for 3 hours, the flopper watched for 2 hours, and the flopper for 1 hour. But let's suppose on a particular date, we tell that topper watched for 2 hours and the flopper watched for 2 hours, and I want to find how many hours the mediocre watched. Can we find? Because we have the assumption that topper always watch greater than or equal to mediocre, and the mediocre always watch greater than or equal to flopper. So in this data we have, the assumption is topper, since he is topper, he watched more videos, more exam fair education videos. So if we assume that we are saying that topper always watched more than mediocre, that means whatever the value of x, if you see this, let's suppose this value is x here, right? 2 is always greater than equal to x, because the topper is always greater than the mediocre. Also we are saying the mediocre is always greater than the flopper. So here the flopper also watched 2. So 2 is always also greater than equal to x. So that means we can say x is nothing but 2, because we are saying that x is greater than equal to 2 and x is less than equal to 2. The only number that can satisfy this condition is 2. So similar to this, we'll develop a sandwich theorem where we'll have three functions, function 1, function 2, function 3. This can be functions where we'll say that function 1 value is always greater than equal to function 2 value, and function 2 value is always greater than equal to function 3 value. That is, topper watches always more number of hours or always watches more or equal number of hours than mediocre. Mediocre always watches more or equal number of hours than flopper. And on a particular date, if topper and flopper watch equal number of videos, then in that case we can say that mediocre also watched same number of hours. You can do a graphical representation also. So let's suppose this is topper, always watches more. This is let's suppose flopper. So this is mediocre actually. This is mediocre also watches less actually, right? This is mediocre. And flopper, this is flopper. Flopper always watches less. But on a particular day, when I'm saying that the topper and the flopper are meeting, right? They are watching the same number of videos. So in that case, mediocre should also watch same number of videos, because we are always saying that topper is always greater than or equal to mediocre, and mediocre is always greater than equal to flopper. Very common thing. And on this we have a sandwich theorem. Please understand this concept very clearly. We have three kind of people: topper, mediocre, and flopper. And the assumption is topper always watches more number of hours education videos, more or equal than mediocre, and the mediocre watches more or equal number of hours than flopper. So we have this condition: T is greater than or equal to M and M is greater than or equal to F. On a particular date, if topper and flopper watches equal number of hours, for example 2 hours, so in that case the mediocre will also watch 2 number of hours, because the condition here is topper is always watching more or equal than mediocre, and mediocre is always watching more or equal than flopper. So we have this condition. If we assume that he has watched X number of hours, the mediocre, then we saw that X is less than or equal to 2 and X is greater than or equal to 2, and the only value that can satisfy this condition is 2. So on the basis of this, we have this sandwich theorem. Sandwich theorem says that if there are three functions, fx, gx and hx, so that hx, I'll draw this. This is let's suppose one function. This is one function, right? And this is one function. So this is hx. Hx is always greater than or equal to gx, and gx is always greater than or equal to fx. So we have three functions, fx, gx and hx, right? They are always greater than or equal to. In for a given point, for example, this point is a. So if for fx and hx, this value for fx and hx, this, let's suppose this value is L for fx, and the same value, that is, let's say h of a is L and f of a is also L. That is, these 2 points meet at L. Then in that case, g of a will also be equal to L. Why? Because the condition is that g of x is always greater than or equal to h of x and less than or equal to h of x. Greater than or equal to f of x and less than or equal to f of x. If these 2 points are equal, that means we can say that g of x is greater than or equal to L and less than or equal to L. So in this case, if you see, the only condition that will satisfy here is that g of x should be equal to L. Similar to what we have done in the explanation, where we have topper, flopper, topper, mediocre and flopper, right? On a given date, when I say that topper and flopper always studies 2 hours, in that case mediocre should also study 2 hours, because if we assume that mediocre studies x number of hours, and we have this condition that mediocre always studies more than flopper, that is 2, and always less than or equal to topper, that is 2. The only condition that will satisfy this condition is x equal to 2. Similar to this, here we have, if we have three functions fx, gx and hx, where the condition is that fx is always less than or equal to gx and gx is always less than or equal to hx. In that case, if for a particular point a or for a particular number a, if limit of, or the value of fx at x is equal to a, or x tends to a is equal to the value of hx, this function at x is equal to a is equal, that means the value of this function, the gx at x is equal to a, will also be equal. That means all these 3 points will coincide. This is what we call sandwich theorem. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.